Welcome to this video demonstration. I'm going to show today how you can start with the scan data like the one on the screen and how you can fully reconstruct an impeller like the one here. The scan data are available for you to download into the description of this video, so feel free when this is finished to download and exercise yourself. So let's begin. I'll close this document for now and we'll create a new part document. Before you start, you need to have our add-in, which is called Mesh2Surface. When you install it, it will appear just as a next toolbar of the SOLIDWORKS command manager. Now before we begin, I will import the STL, not with the file open of SOLIDWORKS, but we'll use the import command of the Mesh2Surface. The reason for this is that we handle the data ourselves, including the rendering and all the algorithms to process such data. Because STL file format is unitless, which means there is no information of the measurements and what the numbers means, whether they are millimeters, meters or inches, you need to specify this and tell SOLIDWORKS. In this case, I know it's millimeters. I'm not going to change the orientation and we'll bring the data as they are. So once the data are loaded, you can see them on the screen. Because SOLIDWORKS has a bit of weird behavior of the shadowing when you import an external file, what you need to do is just point to the button for Apply Scene, click on an arrow and select the plain white. This will actually make the rendering properly and you can see now the scan data correctly. Before I begin, I will start exploring what I need to do. First of all, I need to see how this is placed in space, and I put it in the standard views. Where I see that this is a revolved body, and then I have my blade here, so it's important where is my origin. I'll just highlight to see, and I see that it's properly aligned. Also, I will take my right and the top plane. The reason for this is because I want to define my z-axis, and we will use the standard SOLIDWORKS reference geometry button. Here I will create my axis and press OK. Now I have my axis on the screen. For the ease of understanding, I will just rename it so I know what this is, and I'm going to use it a bit later for all my revolved surfaces. So let's understand now what we want to achieve. From what I see intuitively, I need to reconstruct the main body and then I need to create the blade. Once I create the blade, I will just create a pattern. In this case, I know that there are 12 instances, so this will be the last step and this is quite easy. But before that, I need to start reconstructing my body. To help us with this, Mesh2Surface offers a lot of interesting and good tools. I will now switch to Mesh2Surface tab and will select my z-axis. When I select it, I have an extra icon which is called Create a Revolved Cross Section, or I can choose it from the main toolbar. I can just here pick it from the context menu. So what do we have here is a section plane, what it's called. I can just move it and it will just create a section and place it where we started from. Again, I can just click and get this section here, but whatever I do, I don't really get a good and nice profile for me to help with. So I'll place this my plane on the standard plane, and what I'm going to do is use something which is called the outline. The amazing thing of Mesh2Surface here is that it actually would outline this even in a rotational way, which means that it will take the mesh and unroll it and place everything onto this plane. As you can see here, I can easily extract my profile. And this is so much nicer for me to create my reference. When I'm ready, I'll press OK. So what I have now is the outline of my profile that will help me to reconstruct initially my main body. For now, I don't need my mesh. I'll right click and select Hide the whole mesh. What I need to do now is take the right plane and we'll create a sketch. Because I have everything visible on the screen, this can help me to simply draw my primitives on top of the reference points. But we can also use the Mesh2Surface to help us. For this reason, there is a command which is called FizzSketchEntity, and I'll try to show you what this means. What I need to do is just to extract these profiles, and I can just fit these entities. This will make automatically extractions of the underlying geometry and will detect whether this is a line or an arc. If you want to be strict, you can just select the line. This will not affect whatever you paint on, it will just extract and create a line for you. You can always just undo. Because now I'm focused on the main profile, let's try to extract this. I'll just brush here to get this line. We'll zoom more and just paint on this line and also on this. Here this is a composite curve, so I'm going to extract this line. We'll extract a little bit of this line here, and this is my profile. So far I extracted my main lines that will help me to reconstruct. Probably I also need to get a line here at the bottom. But also what Mesh2Surface offers you is automatic filleting. In this case I can just select this command, which is called automatic fillet, and then just brush over these 2 points where they need to define a fillet. As you can see, Mesh2Surface analyzes the underlying points and automatically determines your radius. You can also probably apply this by holding the mouse button and dragging to this. As you can see now, it intersects, but it didn't manage because it didn't find enough information here. You can also, what you can do here is use the intersect command. That is actually a corner trim, which is similar in SOLIDWORKS, but the way it works, you just brush over these contact points. So I'm ready for now. Before I press OK, I want to make sure that all the lines are fixed in SOLIDWORKS. When I press OK, they will appear as normal entities in SOLIDWORKS sketch. Why I did this fix? Because now, whatever I'm trying to do, my line will be here. So I'm trying to make a full profile of my body. This is probably I need to unfix. So I can just create it vertical, and I can easily adjust to the right position. And I can use now just the normal sketch commands of SOLIDWORKS, like for example, let's create a corner trim here, pick this one, and I'm going to start to close the profile. What I'm going to do now, I need to actually here to make a fillet. We use the fillet command and we'll pick these 2 lines, and now I'm going to play with the results to see where this arc comes. For this demonstration, I will press OK. Probably I can just adjust this until I get a better result, but I will leave it for now. What I need to do here is to close this, and as this is quite a complex shape, I will just use the normal B-spline, and we'll draw this with the several control points. Right click to finish, and at the moment you can tweak this and get the best of your results by moving the entities of SOLIDWORKS. You can adjust, and the good thing is you have underlying reference, so you can easily adjust it and get the most of your results. In this case, for example, I need to make this tangent to get my profile properly. When I'm done with this, I can press OK, and now I have my sketch of my main body. I will adjust my cross section for now, so you can see and understand this. And now is the way to reconstruct our main body. We'll use the standard revolve command of SOLIDWORKS, select this sketch, then we'll go to revolve to extrude, and we'll pick the axis, which is the z-axis in this case. I can press OK, and as you can see, now I have my first solid body. I'm going to hide this for now, and we'll get back and get focused on my mesh here. So what I'm going to do now is try to reconstruct this blade as a solid that will then be combined with the main body. For this purpose, I'm going to use our fit surface command of Mesh2Surface. In order to do this, I need to extract the area which is of my interest and use the mesh selection command. You can use the magic wand here where you can control the sensitivity so it will automatically extract some information. Using the slider you can adjust and get what you want. In this case I just get the main surface and try not to get any fillets because this you can apply later. When I'm ready I can just press OK. Now you see that this remains selected and I can use my fit surface command. This will automatically find surface which goes through the underlying selected triangles and will give you an instant color deviation. Here you can see it only has 5x5 control points and the deviation is really good. I can just press OK, or before I continue, the best will be to actually apply some extension to this surface, and the reason is to make sure that it actually will go through later to do a proper intersection. Again, I can check the deviation, which at this moment is 50 microns, which is absolutely enough. I'll press OK and I will just go and unselect this area. So you can see we extracted this surface. You can always just go and evaluate to see the quality. We can just right click and hide this mesh so you can see how well this approximates. Let's turn off the zebra and bring back the mesh again. What I'm going to do to extract the same surface on the other side, we'll hide this surface for now, and we'll repeat the same process. Going to Mesh2Surface, select mesh selection. Use the magic wand to extract the area that I'm interested in. Probably in this case is too much, so it captures the fillet which I don't really want. This looks good to me and I will press OK. Again, we'll use the fit surface command to interpolate the other side of the object. You can control also the smoothness. The smoother the better, but as you can see you start losing the accuracy here, which in some cases is good because I probably here will create a fillet later. Let's expand this with the 40% and press preview to see. I'm happy with these results and we'll press OK. Now I have two surfaces and I can easily hide my mesh as I will not need it for now. What I'm going to do now, I go back to my initial cross sections, if you remember that we created, and again we'll create another revolved surface by creating another sketch. I don't need this surface body, I'll hide it, and we'll get focus on my sketch. We'll get here and place the view. This time, instead of focusing on the main body, we'll just try to extract the surface that will define my blade. Again, let's go to Mesh2Surface and use our fit sketch entities. I see that I have pre-selected lines. We'll brush to extract this line easily. Click here to get this line and this line. I will also need this line to be extracted. In this case, I'm going to round and use this automatic fillet detection, probably here also. And here it is your choice if you decide this to be sharp or rounded. Let's just use the intersected button and then I just brush here to get a sharp edge. So now I will just press OK. What I'm going to do in SOLIDWORKS is actually extend this and bring it inside the main body. The reason for this is that when we get the blade, we need to have a proper overlaps of the two bodies so they can actually join together when we use the Boolean operation. I need to close the profile because this is important. I don't need to be accurate. I'll just go to sketch and choose 3-point arc. this will be easier for me. Pick the first one and second one, and just do something like this. Again, this arc doesn't need to be accurate, but as long as it goes into this main revolved body. So I'm happy with these results. I press OK. What I'm going to do now is select this sketch, and from the feature we'll create revolved body. I'm going to hide now my cross sections because I don't need it. Now I will use the two surfaces, we'll show them on the screen. And what I'm going to check first is to make sure that the surfaces actually go out of this solid body. This looks okay to me, and this looks okay to me also. What I'm going to use now is the command which is called intersect, and we'll pick my revolved body and the two surfaces. We'll make sure we create both and press intersect. So I created the different parts, and what I'm going to do, click on this one to make sure that SOLIDWORKS remove this, and what I'm going as a result will be one single solid body, which is the result of the intersect. In this moment I will just hide my two surfaces, I no longer need them. We can enable now our main body, the revolve one, so you can see how far we've been. And before I continue, I will just select my body, and what I'm going to do is create a circular pattern. First we need to choose the z-axis that will be used. And now, instead of features and faces, I'm going to select bodies and will pick my intersect. The result. At the moment it offers us 8 number of instances, but again you can check this with your customer. I know that this is 12, I'll just press OK and I get my results here. What I have here is actually a lot of bodies. This means that they need to be combined. Let me hide the z-axis first. The way I can do this is just by selecting all of them and just go to Insert, Features, Combine. So again, I need to choose all the bodies that I need to combine. I will just use the mouse to select all of them. And now make sure that you choose the operation which is called Add. Press OK, and now you can see that everything has been combined into a single body. You can see that we have our original surfaces that we created and only one body. I will just show my mesh at the moment so you can see the overlap. There are still selected triangles. The way you need to unselect them is just by right clicking on the mesh and then select the button which is called deselect all the triangles. What I have here now is my final results. At any point with Mesh2Surface you can use our very fast compare method, which allows you to get a cohort deviation of your results. As you see, I didn't pay attention on the profile which I created here for my main body, so that's why it's off the tolerance, so you can now go back and improve your results. But everything else, if you can see on the plate, is so perfect, and it's still under 50 microns. So this was the tutorial. I hope you enjoyed. Download the file and try it yourself.